Hey friends, welcome to this tutorial reproducing SQL queries in Python as part of my Python tips and tricks series. In this video, I'm going to show you how to reproduce the SQL queries using Python. If you have not already subscribed to our channel, please do subscribe by clicking on the subscribe button below, and also don't forget to click on the bell icon next to it. This video is mainly about how to rewrite the SQL queries in Python. I found that many a times it's really easy to work in SQL because I came from a SQL background. But after practicing, I found that it's pretty easy to work in Python compared to SQL, and there are a lot of options that is available in Python which we can't actually do in SQL. I'll be using the AdventureWorks database for running the SQL queries in SQL Server Management Studio, and for Python code I'll be using PyCharm. I'll be using a view based on sales order table, and I've also extracted the data into a CSV file. I'll be using this CSV to demonstrate using Python. Before starting, I'd like to tell you that the source code and the data set is already available on our GitHub account, for which the link is provided below in the description section, so you can utilize that if you want to practice along. If you've already worked on SQL, you know that SQL statement consists of many clauses. First, we start with select, followed by a list of columns. This is followed by from, and we specify either the table, the view, or a subquery from where we need to extract the data. Next comes the where clause, which is followed by one or more conditions, and then we start with the group by clause, which specifies columns on which we need to group by. This is followed by a having clause and a set of conditions. Then finally we have the order by and the offset. So this is what I'll be covering in this video. The remaining will be for the next part. Now let me show you how to reproduce the same in Python. There are many ways we can write. This is not the exact way, but this is how I am going to cover most of the statements in Python. So in Python, we're going to first start with the from clause replacement, which is nothing but the data frame which we are going to show, followed by the name of the data frame, followed by the condition, that is the where clause, which is going to be followed by the group by clause. So this will be followed by the having clause, and then we are going to have the select, which is where we provide the list of columns that we would want to see. Finally, we'll have the order by, which is going to sort the results that we get out of the query. So this is the approach I'm going to take when I'm writing my Python code. Why do I take this approach? It's a good way to practice this, so it makes it easy for us to understand, and also it improves the performance. So I'm going to stick to this format in this entire video. I'm starting with a simple select statement, which is going to select all the columns and all the rows from the view. You can see the result after executing. I've received 31,465 rows. So that's the total rows that I have received from this query. Let me reproduce this in Python. So I'm going to use PyCharm for as the editor, and I'll be using Pandas library for reproducing the SQL queries. So I'm going to import Pandas. Next step is to read the data from the CSV file. I'm going to create an object called SD, into which I'm going to store all the data that I read from the CSV file. This is going to be of type data frame. I'm going to use the pandas read CSV function and pass the path of the CSV file, and that's all that I need to load the data into the data frame. Now this statement of reading everything from the CSV is equal to select star from the SD table. Now I've got the entire result set into this variable SD. Let me print that and show it to you. All I need to do is I can say SD and then go ahead and execute. I get the same set of rows. 31,465 rows and all the 22 columns. Next, I'm going to show you how to select a few columns from the view or from the data frame. I'll copy the previous query and just modify it so that you will know what are the changes that we'll be making. So instead of star, now I'm going to use sales order ID, order date and sales order number. So these are the columns that I'm going to select. You can see the result over here. I got the results. Again, I got 31,465 rows with only these 3 columns. Let me reproduce this in Python. How to get the required columns? There are many ways. One of the ways is I'm going to say sd dot. Suppose I want just one column to be selected. I can directly go ahead and give the name sales order ID. You can see here I got all the rows, 31,465 rows, and for that particular column. This is not the only way to extract columns, so I'm going to show you a few more ways. We can do that in Pandas. The second approach which I'm going to show you is we can use the data frame, and within square brackets we can give the column name like sd square brackets and column name. I can extract, I get the same result. Now this is for one column. How about more than one column? In that scenario, again there are many approaches. I'm going to show you 2 approaches. One is using the same approach that I have followed here. I'm going to use sales order ID. So here, because I want more than one column, since there are more than one columns, we have to provide it as a list. Let me create a list over here. So I'm going to say columns is equal to sales order ID, order date and sales order number. So these are the 3 columns that we want. Here you can directly provide this list as it is instead of storing it into a variable. It works. Now let me execute that. You can see that I got all the rows and the 3 columns that I wanted. Or instead of this way, I can store the columns in a variable and I'm going to use it as well. So that is what I'm going to do it now. You can see I got the output what was expected. Now I'm going to show you another approach using the function loc. sd, that is the data frame dot loc, and then within square brackets, pandas data frame dot loc attribute is used to access a group of rows and columns either by providing labels or a boolean array in a given data frame. It accepts rows and columns as parameters. First comes the rows and then comes the columns. Instead of rows, I'm just passing a colon over here. That means I want all the rows. For columns, if I again provide a colon, it will pick all the columns, but since we only want the 3 of them, so I can pass the column names as a list, something like this. Or in this case, we already have it stored here. To keep this statement simple, I'm going to use a variable over here. When I go ahead and execute this, I get the rows, but only the 3 columns that we have asked for. So this is equivalent to our statement select sales order ID, order date, sales order number from SD. Till now what you saw was it was getting all the rows. Now let's see how to extract only a few rows that we require. Let me go back to SQL. I'm going to extend on the same statement to demonstrate this. Now I'm going to show you how to extract only a few set of rows from the beginning. It's very simple in SQL. Before the columns, use the keyword top and specify the number of rows that you would want from the beginning, and we get our results. So in this case, I got top 10, but it returned only these 3 columns. If I want more than these columns, either go ahead and add more number of columns that you would want, or remove the column numbers and add an asterisk to get all the columns. So it gives all the 22 columns for me. Now if I want only a few rows and a few set of columns, this was the previous query that we executed. So now let us try these 2 in Python. First, let us go with the first few rows with all the columns. That's very simple in Python. The data frame dot head function, and I'm going to say the number of rows that I want, 10. So now if I execute this, you can see that I got 10 rows and 22 columns. Here the result is, you can see these dots, it says that the result is curtailed. If you want to see whether if I am getting everything or not, let me go ahead and store it into some variable and then show it. I am going to say the variable name as sliced SD, and I am going to store everything into that. You can see here it's a data frame. It contains 10 rows and 22 columns. Now let us go ahead and extract the top 10 rows, but with only the 3 columns that we want. I'm going to use the same statement that we used for extracting the columns and extend it by entering dot followed by head, which is the function, and then the number of rows that we want. That's all we need to do. This is not the only way. There are various other ways. So now I'm going to show you one more way of extracting the same thing. We can use just this part of the code. So here I'm going to say from 0 to 10. So here in this case I'm specifying get me the rows from 0 to 10 for and only these columns. So when I execute this, I get the expected result. We're getting 11 rows, but we were expecting 10 rows. That is because it returns all the rows including 0 and 10. So I can go ahead and decrease it and say 9. So we get 9 rows. I'm going to show you another approach, which is dataframe.iloc. This iloc method is primarily integer position based. That is, it accepts values from 0 to the length minus 1 of the axis. But it may also be used as a Boolean array. It uses the index values instead of the column or row names. So I'm going to use that sd.iloc, and then here I'm going to give the values as 0 from where to start, and then 9 where it has to end, and columns. But as I said, the columns is a list of strings, and iloc only uses numbers. So we have to provide the numbers. So how to get the index value of each column? We can use the function dataframe.columns, and it will give us a list of all the columns that are available. We can provide the index value of each column. The index of the column that we require are 0, 2 and 7, and execute this. Now you can see I want rows from 0 to 9 and then these columns, and it worked. It's something similar to this, but here we gave the actual column names. Here we are giving the index of the column numbers. When we are selecting columns, we can give the exact column number index, or we can go ahead and use the start and stop approach as we have done for the rows as well. So here I am saying 0 to 2. That means I want all the rows from 0 to 2. Here it doesn't include the column 2. It only gives us the columns 0 and 1. There's something else that I would want to show you. We can use this approach when querying a set of rows but I don't want everything in a series. I may want to step over a certain rows in between in an order. So that is like I want to get all the even rows or all odd rows, or I want all the rows from 0 to 50, but I don't want every row, but I want every fifth row. So I'm going to say :5. That is step 5. Let me replace the columns with the column indexes that I want. Say 0, 2, 7. So these are the columns that I want every fifth row. Now when I enter this, you can see that in the result I've got 3 columns. I've got first row and then the fifth row and then the 10th, 15th, 20th. It's quite complex to achieve this in select statement, but pretty easy in Python. You saw how to get the top certain set of rows or a certain set of rows by stepping over some. But what if I want to get the last few rows, say like the last 10 rows? To achieve this in Pandas, it's very easy. Just replace the head function with the tail function and we get our results. If we have to do the same thing in SQL, it's not pretty straightforward. For that, what we need to do is, first we have to say top 10 only, but I need to sort it in a reverse order. Order by sales order ID and descending. So now if I execute that, you can see I've got the last 10 rows and the first 10 rows. But one thing that you need to understand is that it won't give it in the order the way we have stored it in the database. That is not easy over here in this case. But in Python, that is pretty easy. Next, I'm going to start with the where clause. Where clause allows us to add conditions so that we can filter the results that we are getting. So I'm going to use the previous statement and extend upon that. Notice it returns all the rows from the view. So I'm going to put a condition wherein I would want the orders from a particular ordered date. Let me copy over this previous statement and add the where condition saying where order date is equal to this particular date. So when I execute this, I get all the records. You can see here I've got totally around 43 records for that particular order date. If you notice in this where condition, there is only one condition which says order date should be this particular 30th of May. But what if I want to add another condition to say that it should be greater than a particular order number? So let me show that. So let me add another condition to this saying that the sales order number should be greater than a particular number. So I'm going to say and sales order number greater than 43,675. So this just make some random number. So this is another condition. So when I execute this, okay, I gave a wrong column number. It should be sales order ID, not sales order number. Let me change that and execute it. I've got totally around 26 rows. The order date is same, but you see the sales order ID, it is greater than the number that we have asked for. In this way, we can go ahead and give multiple conditions using the and or to filter the records. Let me show you how to reproduce this now in Python. Now remember the order that I spoke about in the beginning of this tutorial. We are going to start with that approach wherein the first we're going to have the data frame, and then we are going to use a where clause, then group by, select and order by. So I'm going to follow the same now. The data frame name SD, then followed by square brackets. Within this I'm going to give the where condition. What is the where condition? In this data frame SD, the order date, and then remember this is how we select the column. So order date is equal to this particular date. So for this condition, what are the columns that we require? We already have the columns stored in this variable columns. So I'm going to use it over here. So when I execute this code, notice we get the exact same result as we got when we executed the select statement in SQL. Now let us try with multiple conditions. So I'm going to use the same code and extend it. So I'm going to enclose this condition within round brackets and then followed by an ampersand to represent the and which we had in SQL, followed by another column name which is the sales order ID, and then the condition will be it should be greater than 43,675, same as what we did in SQL. Like this, you can go ahead and add any number of conditions based on your requirement. So now let us go ahead and execute this code. Notice we've got the same exact number of rows and columns as we got when we executed this query in SQL. You can see I got only the rows from 17 onwards. Okay, and you can see the sales order ID, it starts from 43,676 because I've said everything greater than 43,675, so I'm getting only those records. So this is how we use the where condition. Now let us see using the where clause combined with the in keyword. The where clause, when combined together with the in keyword, only affects the rows whose values matches the list of values provided in the in keyword. So in this way, the in keyword helps us reduce the number of and or clauses which we may have to use. Let us see how to use the in keyword in SQL and then come back to Python. So let me start by modifying this select statement. As of now, there are two conditions. One is order date is equal to a particular date, and sales order ID is greater than a particular number. So I'm going to keep the first condition, but instead of saying sales order ID is greater than a particular number, I'm going to pass a list of sales order IDs for which I want to see the records. Okay, that we can do by using the in condition, and within the round brackets we can go ahead and provide a list of sales order numbers, or we can actually go ahead and even provide a subquery within that. So in this case, I'm going to provide a list of sales order numbers. So if I run this code, I get the sales order for only those three sales order numbers. I get the records. This is how I can slice. So I can go ahead and give a list over here, and it will slice for that list. So let me copy these three and show you how to get the same result in Python. So I'm going to use the previous condition and modify on that. I'm going to keep the first condition as it is, and then I'm going to modify the second condition. Instead of saying sales order ID greater than, I'm going to say sales order number is in. So is in is the function that we are going to use, which will replicate the in keyword from select statement. I'm going to pass the same list of order numbers. Let me execute it now. You can see that we get the same exact result. Not just this, we can also provide a list containing a set of numbers. The way we have provided here, we have directly provided the numbers. Instead of that, we can load the values from a file or a table or in any form, save it into a variable, and then directly provide the variable instead of the numbers. So let me create a variable called filter numbers, and then I'm going to use this variable to pass as a parameter for the isIn function, and we are going to get the same exact output. So that's about the where condition. Now let us move on to order by clause in SQL, that is sorting the results that we get. So I'm going to change, I'm going to use this select statement, but instead of proceeding with the same columns, I'm going to change it a little bit so that the examples, what I'm going to show, will be more appropriate by using the territory ID and subtotal column, which I'll also be using for the group by and having clause. I'm going to use just one condition. So in order to sort records in select statement, we use order by clause, followed by the set of columns on which we would want to sort the records. This is followed by the keywords ascending or descending, but since ascending is default, it's not necessary to provide it specifically. So here I'm going to use order by subtotal. When I execute this statement, you can notice that like the lowest subtotal comes first, followed by the higher numbers and the highest at the end. It is sorted in ascending order, even though I have not provided the ascending keyword. Notice that when I provide the keyword descending, I get the exact opposite result, wherein like highest value of subtotal will come at the beginning and the lowest comes at the end. So now I'm going to reproduce this in Python. So in this case, I have kept only one condition as we did in the select statement. So I'm going to change the list of columns that we were using to replicate the same select statement from SQL. So here in this case, if you notice, I have one where condition and then a list of columns. To sort the results, we are going to use a function sort underscore values, and that takes a set of parameters. So in this case, we are going to use a parameter by equal to, and then we have to provide a single column name as a string or a list of column names, which we can provide. For that, we can followed by another attribute called ascending, which accepts a boolean value, true or false. By default, it is true, but you can set it to false if you want to sort the result in descending order. For this example, I am going to sort the values by the column subtotal. Now when I execute this, notice that I have got the lowest value at the top followed by the highest value. So now the records are sorted in ascending order as we got in the select statement. Let me show you how to sort in descending order. All we need to do is set the value of ascending attribute to false. Thereby we get the results in descending order. When I execute this code, you can notice that I've got the results in a descending order. That is the highest subtotal value at the top and the lowest at the bottom. Next, let us look at the group by clause. A group by clause is used to group rows that have the same values. The queries that contain group by only return a single row for every grouped item. The group by clause is usually used in conjunction with aggregate functions to produce a summary report from a database. In order to show a group by example, it's always better to have a lot of rows, and hence I'm going to instead of filtering on a particular date, I'm going to just add a condition so that I can demonstrate group by can be used with a condition, and because of that I'm going to pick all the records where the subtotal is going to be greater than 2500, so that we are going to get a huge chunk of records. At the same time, it's already filtered. Group by clause comes after the where clause but before the order by clause. So the group by works on the results of the where clause, that is whatever the results that we get after filtering the data using the where clause, on that the group by will be applied. I'm going to use group by to group all the records based on the territory ID to find out the total sales for each territory. So in order to group by territory ID, after the where condition, go ahead and provide group by and then the column name, which is the territory ID. Okay, so that is all we need to add over here. We don't require the sales order ID and the order date because we are going to group by territory ID. So I'm going to remove them. Now we have got the records group by territory ID. I'm going to use the aggregate function sum to get the total of all the subtotals for each territory. That is all we need to do to get the total sales for each territory. Let me execute the code now. Okay, there is an error. That's because we don't have a column called subtotal because it's been aggregated. So let me go ahead and give an alias for the aggregated column as total and use the same thing in order by clause. So now you can see that I have received the territory IDs and the aggregated subtotal value for all of them, and this result is sorted based on the total column, that is lowest at the beginning and the highest value at the end, that is it is sorted in ascending order. Now let's reproduce the same in Python. So now we are going to use the group by. A group by is not one single thing. There are many things that is happening, that is split, apply and combine. So whenever we say group by, we are referring to a process involving one or more of splitting the data into groups based on certain criteria, then applying a function to each group independently, and finally combining all these results into one single data structure. So out of all this, the split step is the most straightforward. So that is like when we say group by a particular column. So in our case, if we say group by territory ID, we are actually splitting the data on territory ID. Then comes the aggregation step, that is applying a function. So here we are going to apply certain function like sum, average or calculate median or count. So in our case, we are going to apply the sum function to find out the subtotal. So when we use the sum function, we are aggregating on each of these groups independently. And finally, what we do is we pick the results and then we combine everything into one single data structure. Let's apply this group by logic on the previous statement that we worked. First step is to go ahead and change the condition. So instead of order date, I'm going to pick only those records where the subtotal value is greater than 2500. Next, I'm going to use the groupby function, and within the square brackets we can provide a list of columns on which we need to group by, and in this case it's going to be territory ID. And then I'm going to add an aggregation function to sum the values that we have split on territory ID. So this aggregation function is going to be applied on a column. In our case, it's going to be the subtotal column, and the aggregation function name is sum. Like this, we can go ahead and provide any number of aggregations on a single column or multiple column, which we are going to see later on. Since we have grouped the records, I'm going to use a reset index function. This reset index function is used to reset the index of a data frame, and I'm going to use a LOC function instead of directly providing the columns. I'm going to select all the rows and specify the territory ID as the column which I want to display, followed by the aggregated column, which in our case is subtotal over here. Now when I execute that, you can see I get the same response as we got in case of SQL. The reason you see the subtotal values in scientific number format is because we are printing them in Python console, and that's how it's displayed there, because if it is a huge number, but the values are actually stored in a normal format. Here if you notice, the data is ordered in ascending order based on the subtotals. So in order to sort the data in descending format, we can set the ascending parameter to false. Now if you notice, the values are sorted in descending order with the lowest number at the bottom and the highest number at the top. We just now saw how to go ahead and group by one column and using a single aggregation function. Now let us see how to go ahead and group using multiple columns and using multiple aggregation functions. Till now we saw how to get the subtotals by territory ID. What if I would also want to see the number of transactions that has happened? So let us try that now. So the next thing that we want is to get the number of records for each territory. So for that, I'm going to use another aggregate function called count, and I'm going to use the same column subtotal to aggregate, and that's all I need to do in SQL. Now if I run the code, notice that with the subtotal I'm also getting the number of orders, but the data is still ordered by, or the sorted by, total column in ascending order. Now let me go ahead and reproduce this in Python. So now we want to see the number of transactions, right? So earlier we were using only one aggregate function sum, so we are directly given it as a value as a string. Now I'm going to make it a collection, that is a list, and then the first one would be the sum, then the second aggregate function that we're going to use would be count. So now I get two columns, so we need to also include them in the column list. So I'm going to change there as well. We're going to have a list of columns, territory ID without any aggregation, then subtotal with the aggregation as sum, and then the next column would be subtotal with count. And also, since the columns have changed, and I'm going to specify that we need to sort by ascending on the subtotal column which has been aggregated using sum. If you see the results, it's exactly the same as we got in SQL. So that is how we get multiple aggregation using a single column. What if I want to do multiple aggregations using multiple columns? Let me show you this with another example. In this case, we used two different aggregation functions, the sum and count, but we just used one column which was the subtotal. I'm going to modify this, but you won't find it much use, because I'm going to, instead of using subtotal, I'm going to use territory ID for the count. That's just to demonstrate how we can do the same. So in this case, I'm going to replace subtotal with territory ID for the count function as the parameter. The results are not going to be any different from the previous one. It's just to demonstrate that we can as well do this to. So I'm going to reproduce the same thing now in Python. Notice the changes in this code. Instead of setting the columns through LOC, I'm directly providing the list of columns, and then I'm providing the where condition followed by the group by. Here it's going still its territory ID, but in the aggregation I'm using subtotal as well as territory ID. Territory ID with the count aggregation function. If you have any other columns to be included into the aggregation and then add any other aggregation functions, you can continue the same process. Now you can see when I execute the code, we get the exact same results as we got in select statement. Now let us see how to go ahead and replicate the having clause, which is the last thing that I'm going to cover in this video. I'm going to use the having clause now to filter the results that we have got after grouping. I want to see only those territories where the total sales has exceeded 5 million. Okay, for that, after group by, we can just go ahead and say having sum of subtotal greater than 5 million, and that is all we need to do in SQL. If I go ahead and run this code, you can see I get only those records where the total sales is greater than 5 million. Now let me reproduce this in Python. To keep it very simple, I'm going to create a new variable and store the results of the statement that I have written above into it. And then I'm going to use a condition on that variable to filter the results. This will produce the same result as we got by using the having clause in select statement. This was the previous statement that we executed in Python. So this statement returns the records grouped by territory ID, and it also returns two more columns, the total column, which is the sum of all the subtotals for that particular territory, and also returns the number of transactions. Now we want to see only those records where the total value for that territory is greater than 5 million. So now this result, what we received, I'm storing it into a temporary variable called temp. Now I'm going to use this temp variable and use a where condition on that to filter out the records which we want, that is total value greater than 5 million. So I'm going to say temp, and within square brackets I'm going to say the subtotal greater than 5 million. Now if I execute this statement, I get only those where the total value is greater than 5 million per territory. It's exactly the same as we got in select statement. This is how we can reproduce most of the things that we can achieve in SQL statement in Python. In the next video, I'm going to cover joins and a few more complex scenarios. That's it for now, friends. If you have not already subscribed to our channel, please do subscribe by clicking on the subscribe button below, and also don't forget to click on the bell icon next to it. Thank you.